And again, happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. While I'm thinking of it, I want to remind you of something I mentioned when I talked to each of you individually on the phone before class ever started. I don't look for messages in WebAssign. So if you're sending me messages in WebAssign asking for an extension or want to know what my shoe size is or what I want for Christmas, you'll never get an answer. To get in touch with me, email me, okay? I don't look for messages in WebAssign. I just look in email because I can access that anytime on my phone. With about 90 students, I don't want to look a whole bunch of different places. Don't use Canvas. I don't use WebAssign to send messages or get them. Okay, so today we're going to review for the Chapter 9 test. And we're going to start off with some questions that were requested through email. So let me get to those. This is from the Chapter 9 review, and we're going to start with number 15. The directions say, simplify the expression. All variables represent positive real numbers. What that tells us is that when we're dealing with the variables, we don't need to worry about absolute value. If we're taking an even root, we don't have to be, we don't have to be concerned whether the answer is positive or negative. The variables represent positive numbers. Okay, so here's the quantity, negative 243, x to the 10th, y to the 5th, the whole thing to the 4/5 power. So we have a product raised to a power. So the first move is going to be to take each factor in the product and raise it to the outside 4/5 power. Okay, so that gets us that. Clean that up a little bit. Now let's take these pieces one at a time. Let's do the first one there. So negative 243 to the 4/5 power is equal to negative 243 to the 1/5 power, and then that raised to the 4th power. In other words, I can do the root and then the power as long as they're both real, and in this case they are. So I need to figure out what the 5th root of negative 243 is. There's a couple of different ways I can do this. One of them is to do it by hand. And if I do it by hand, I'm going to say, well, negative 243 is negative 1 times 243 is negative 1 times 3 times 81, which is negative 1 times 3 times 9 times 9, which is negative 1 times 3 times 3 times 3 times 3 times 3, and finally negative 1 times 3 to the 5th power. So I'm doing the prime factorization after I took out the negative 1. So dealing with that, what is the 5th root of negative 1? Well, in other words, let's apply that. Well, let's do it this way. So negative 1, the 5th root would be negative 1. 3 to the 5th, the 5th root would be 3. So I get negative 1 times 3 or negative 3. But all of that now gets raised to the 4th power, okay? Negative 3 to the 4th power, negative 3 times negative 3 times negative 3 times negative 3 is 81. So 81, okay, that first thing. Any questions about that piece? That's the most complicated piece in this problem, okay? Next piece, a power raised to a power, you would multiply the exponents. 10 times 4/5 or 40/5 would be 8. So we get x to the 8th power. Any questions there? Okay. And then the last piece, y to the 5th to the 4/5, we multiply the exponents. 5 times 4/5 is 20/5 or 4, so we get y to the 4th power. So here is our final answer. Any questions about that before we go on to another example? A lot going on there. All righty. Still in the chapter review, this is number 22. And let's see here. It says, simplify the radical expression. All variables represent positive real numbers. Okay, so again, we don't have to worry about absolute value. We're taking the 4th root of 162 x to the 12th, y to the 4th. All right. Since my index is a 4, inside the radical, that is the radicand, I'd like it to have things raised to the 4th power or to multiples of 4 powers, okay, like 4, 8, 12, etc. Let's deal with the 162. 162 is 2 times 81, which is 2 times 9 times 9, which is 2 times 3 times 3 times 3 times 3, which is 2 times 3 to the 4th power. So I'm going to rewrite this radical as the 4th root of 2 times 3 to the 4th power times x to the 12th power. 12 is a multiple of 4, so that's good. Times y to the 4th power. So 4 is a multiple of 4, 4 times 1. So now I have powers inside that are either 4s or multiples of 4s, and then leftovers. All right. This is a leftover. It's going to stay inside. I can't get rid of it. But moving on, the 4th root of 3 to the 4th is a 3 outside of the radical. The 4th root of x to the 12th would be x to the 3rd. 12 divided by 4, outside the radical. Y to the 4th, the 4th root of that would be y. And what do I have left inside? 2. So final answer, 3x cubed y times the 4th root of 2. Any questions about that? One of the biggest mistakes that students make is they forget to put the index in. I've had students back in the day when we did this in the classroom that would ace this test, except they'd miss one thing. They would leave an index off. If it's a square root, you don't have to put a 2 there, but if it's any other root, you have to put the index there, okay? All right, finally, still in chapter 9 review, we've got number 24, and that says, simplify the radical expression. Again, all variables represent positive real numbers. So again, we don't need to worry about absolute value bars. The square root of z squared divided by 4x squared. Because we have a quotient inside of a radical, we can take the numerator inside a radical over the denominator inside a radical, but the index stays the same. All right. The square root of z squared is z. The square root of 4 is 2. And the square root of x squared is x. Again, I don't need any absolute value bars because the instructions said that all variables represent positive real numbers. So here is the final answer. Any questions about that one? Okay, well, that's all the questions that people emailed to me. So next, do you have any questions you'd like to look at? Anybody, any specific questions? All right, well, let's go back and kind of do some highlights from each section of this chapter. Let's see. 9.1. Here's where we first introduced the idea of absolute value. And that goes back to a couple of facts that we need to review perhaps. And that is, if you take an even root of a negative number, you don't get a real answer. Okay. Now, there are imaginary numbers. We're not going to go there. You don't need to cover that in this course, but basically that's what you end up getting, but you can't. So if you take an even root of a negative number, you don't get a real answer. So let's say I've got the fourth root of negative whatever, -5. It's going to be not real. Okay. And sometimes the author also calls it undefined. Again, read the directions to the problems. Okay. Secondly, if you take an even root of a positive number, you don't get a negative, oops, helps if I could spell, negative answer. Okay. So the square root of some positive number cannot equal a negative answer. Okay. Now, where does that come into play in terms of absolute values? So let's say we've got the following situation. We've got the square root of x squared. And the directions say this: simplify each expression, but then it says assume that all variables are unrestricted. So that means that x can be positive, can be negative, can be 0. Well, if I take the square root of x squared, I'm going to get x. However, since x could be a negative number, to assure whoever that it's not negative, I need absolute value bars. For example, let's say I took the square root of -3 squared. Well, the square root of the square, you get -3, but it can't be negative, so you'd apply that, which would give you a +3. Okay, so the square root of the quantity -3 squared is 3. Another way of looking at this is that this is that, which is that. Okay, now in this case, I would just write the final answer as a 3 because I know the absolute value of -3 is 3. Here, since I don't know what x is, I have to just leave it as the absolute value of x. All right, now let's say I take the cube root of x cubed. Likewise, I get x, only now I don't need absolute value bars. In fact, it would be wrong to apply them because with an odd root, you can take an odd root of a negative number and you can get a negative answer. For instance, the cube root of -4, the quantity cubed, would be -4. What about the square root of x to the 4th power? Well, that would be x squared. However, even though it says the variable is unrestricted, if x is positive, positive times positive, or positive squared would be positive. If it's 0, 0 times 0 would be 0. If it's negative, if x is negative, a negative times a negative would still yield a positive answer. So there's no way that that answer is negative. Consequently, I don't need absolute value bars on it. Okay. So rather than trying to memorize, a bunch of rules to do with this, I would say take it case by case. If you're taking an odd root, you don't need to worry. If you're taking an even root, then you need to look at the answer and say, well, if it's unrestricted, could that be negative? If it is, I need to put absolute value bars on it because when you take an even root of a number, you can't get a negative answer. Okay. Another thing that comes up in this section that people tend to miss, has to do with finding the domain of a function. All right. if you have some function and you're taking an even root, so square root, fourth root, sixth root, okay, if the index is even, and you're asked to find the domain, we go back to, let's see here, this rule. If you take an even root of a positive number, you don't get a negative answer, okay, good. But if you take an even root of a negative number, you don't get a real answer. Excuse me, I read this one wrong. Forget that one for the moment. Let's go back to this top one. If you take an even root of a negative number, you don't get a real answer. So that means, since I'm taking an even root, this can't be a negative number, which means it has to either be positive or equal to 0. So when you're asked to find the domain of a function where you're taking an even root, square root, fourth root, sixth root, whatever, take the radicand, the stuff inside the radical, and turn it into an inequality statement, what's inside greater than or equal to 0. Then go back and solve for x. That's going to be your domain, but you need to write it in interval notation. So it's going to be bracket -12, infinity, parentheses, okay? One of the things I saw, I think it was on the last test, is quite a few people, they had the right inequality on an answer, but it asked for interval notation, and they didn't write it in interval notation. So again, pay close attention to the instructions. Let's look at another one of those. Let's see here. H of b equals the square root of 0.4b minus 36. So we're taking an even root. So 0.4b minus 36 has to be greater than or equal to 0. Okay. Solving for b, we're going to add 36 to both sides. Then we're going to divide both sides by 0.4. And let's see, what is 36 divided by 0.4 is 90. So b is greater than or equal to 90. All right. Just a quick reminder, when you're solving an inequality, if you multiply or divide both sides of the inequality by a negative number, then you change the direction of the inequality sign. Let's look at one that has that in it. So h of x equals the square root of 35 minus 5x. Okay, again, they want the domain. I should have labeled this domain. Okay, so we want the domain. So 35 minus 5x greater than or equal to 0. Okay. Subtract 35 from both sides, negative 5x greater than or equal to negative 5. Divide both sides by negative 5, we get x, we get 7, but because we multiplied, or specifically in this case, divided both sides by a negative, we changed the direction of the inequality sign. So the domain would be from negative infinity up to and including 7. Okay, let's see. Anything else I want to highlight on that? No, I think I want to go on. Oh, section 9.2 dealt with rational exponents. So it used all those laws of exponents going back to chapter 5, section 0.1, 5.1, and 5.2. But now we have exponents that are fractions, but the rules still apply. Multiplying two powers with the same base, you add the exponents. Dividing two powers with the same base, you subtract the bottom exponent from the top exponent. Product raised to a power, you attach the power to each factor of the product. A quotient raised to a power, you attach the outside exponent to both the numerator and denominator of the fraction. Something raised to the 1 power, it's just like not writing the exponent, there's an implied 1 there. Something raised to the 0 power equals the number 1, other than 0 to the 0 power, and we're not going to deal with that. Let's see what others. Oh, a negative. If you've got something to a negative exponent, that's 1 over something to a positive exponent. If you've got 1 over something to a negative exponent, that's something to a positive exponent. If you've got a quotient to a negative exponent, it's going to be the reciprocal to a positive exponent. Then, of course, you'd go on to the next step there. I think that's all the rules. Let me take a quick look here and make sure I didn't forget some. Let's see, back on page 364, product. Ah, I did forget one. A power raised to a power, you multiply the exponents. Yeah, that takes care of all of them. Anyway, so you might want to review those. Again, make sure that they're fresh in your mind as to how to apply those. Let's see here. Simplifying and combining radical expressions. 9.3. Recall that if you have the root of a product, you can write that as the product of the roots, as long as each one of them produces a real answer. If you have the root of a quotient, you can separate them into the root of the numerator over the root of the denominator, again, as long as both of them produce a real number. And these are two-way statements. So given the left side, you can get to the right side. Given the right side, you can get to the left side. Simplifying a radical. It doesn't necessarily mean the answer looks nicer. It means we've kicked everything outside of the radical that we can. And we use this fact. The nth root of a to the n equals a if a is greater than or equal to 0. Okay, so if I've got the third root of 42 to the third power, that's 42. Because if I went the long way, that would be 42 to the 3/3, which is 42 to the 1, which is 42. So I can just go straight there, okay, as long as the base is positive. Now, if the base is negative, this rule applies only if you've got even exponents. No, wait a minute, I said that wrong. Odd exponents. In other words, if you've got something like this, okay, the answer is not -3 because again, you run into that problem. Okay, so as long as the base is positive, this works. If the base is negative and we're taking even roots, then we get into trouble and we have to use absolute value bars and stuff. But this works. How do we use that? Well, again, let's say we're doing, we want to simplify the square root of 75. Okay, 75 is 3 times 25, but 25 is a perfect square. So this is equal to 3 times 25, the square root of that rather. And then I can come in and say, well, the square root of 3 is going to stay inside. The square root of 25 is going to be a 5 outside. So I get 5 square roots of 3. Now be careful because I'll have students do it backwards and they'll write 3 square roots of 5. No, you're taking the square root of 25 and kicking the 5 result outside, but the 3 is still inside. Okay. If you've got something like the third root of 27 x to the 7th y to the 4th, you could rewrite that as the cube root of, well, 27 is 3 cubed. X to the 7th you could write as x to the 6th times x, and y to the 4th as y to the 3rd times y. Now, why did I pull them apart that way? Because, as we looked at earlier, first of all, the cube root of 3 cubed is 3 outside. The cube root of x to a power that is a multiple of 3 reduces out nicely. 6 divided by 3 is 2. So the third root of x to the 6th would be x squared. This is stuck inside. The cube root of y cubed is a y outside, and this is stuck inside. So then I've got 3x squared y times the cube root of xy. And let's see, combining like radicals. Again, make sure that you simplify each radical first. So for instance, here's one, 12 plus the cube root of 80 minus the cube root of 10,000 plus 4. So let's take these one at a time. 12 is just going to be 12. 4 is just going to be 4. But let's look at the cube root of 80. Okay, so the cube root of 80, 80 is 8 times 10, which is 2 times 2 times 2 times 2 times 5, but that's a cube, right? 8 is a cube. So if I wrote this as the cube root of 8 times 10, in the next line, I'd get the cube root of 8, which is 2, and then the cube root of 10, like that. So taking this and simplifying it, and then minus. Taking this one, 10,000 would be 10 to the 4th power, or 10 cubed times 10. Again, why am I doing that? Because the cube root of 10 cubed is 10 outside, and I've got the cube root of 10 inside, and then bring down plus 4. So I took this one, simplified it, got that, took this one, simplified it, got that. Now, these go together, 16, and these go together. I've got 2 cube roots of 10 minus 10 cube roots of 10, which is actually going to be minus 8 cube roots of 10. Okay. Let's see here. Any questions on that? Okay. And then finally, section 9.5, which is where we solve radical equations. If we have an equation with one radical term, isolate that term, and then raise both sides to the appropriate power to get rid of the radical. If it has 2 radicals, separate them. So for instance, let's say I've got this, the square root of 6x plus 1 minus 5 equals 0. So the first thing I would do is isolate the radical. Then I would raise both sides to the appropriate power. Since I'm taking the square root, I square both sides. If I was taking a cube root, I would cube both sides. A 4th root, I would forple, whatever, raise both sides to the 4th power. So now I get 6x plus 1 equals 25. Subtract 1, 6x equals 24, divide by 6x equals 4. Whenever you solve an equation by squaring or cubing or raising both sides to the 4th power, whatever, check your answers to make sure they work. So this is 6 times 4 plus 1 minus 5 equals 0. 24 plus 1 minus 5 equals 0. 25 minus, again, the square root of, so I get 5 minus 5 equals 0. So it checks, okay? If you get an answer that doesn't work, then it's known as being an extraneous solution, okay? And again, check the instructions in WebAssign as to how they want you to deal with that. All right. Well, that's all I've got for you, unless you've got some questions. If you want any more examples of anything or whatever, let me know. Okay. So I'll be back today at 1:15 with an office hour. Just a couple of reminders. So your test is due no later than 11:59 p.m. Monday night. There will be no class meeting on Monday. Just take your test. You can take it today. You can take it this weekend. You can wait and take it Monday. I wouldn't wait till 10 o'clock on Monday night. Not a good strategy. Tuesday is advising day. So there will be no class, no Zoom meeting, no office hour, zip diddly squat, okay? So unless you show up for today's office hour, the next time I will be talking with you would be on Wednesday. All right? Any questions about any of that? Be sure that you contact your advisor on Tuesday if you need to have advising. Anyway, I'm going to go ahead and stop the